Good morning and welcome to Physics 365. Physics every single day of the year. Physics past, present, and future. The podcast doors are closing.
All right, friends, hello and welcome to Physics 365, where all we do is think about physics every second of every day of every year. I am your host, Eli Hibben, and today, 29th of January 2016, Friday, let's take a look at this day in physics, 29th of January 1926. We say happy birthday to Abdus Salem, one of three physicists to share the Nobel Prize in 1979 for unifying the electromagnetic and weak forces into the electroweak force. So, man, we got a lot of Nobel laureates going on in January, so, well, hopefully that'll keep up throughout the year. We'll see what happens. So that's what happened in physics history. Let's take a look at the word of the day, mass. So first, let's take a look at a couple of definitions. From Wikipedia, it is generally the amount of matter of an object. It is determined by the strength of its mutual gravitational attraction to other bodies, its resistance to being accelerated by a force, and in the theory of relativity gives a mass energy content of a system. The SI unit of mass is the kilogram. So what I've gotten so far is that the unit of mass is the kilogram. So maybe that's where you are too. So let's carry forward and take a look at hyperphysics. The mass of an object is a fundamental property of the object, a numerical measure of its inertia, a fundamental measure of the amount of matter in the object. Definitions of mass often seem circular because it is such a fundamental quantity that it is hard to define in terms of something else. Isn't that the truth? So far, the word matter has come up in both definitions, and we have the unit of mass is a kilogram. So let's dig a little deeper here. So unofficially, mass is quote unquote how much stuff there is. It can be quantified in a couple of ways. First, as mentioned in both definitions, it is a way to quantify inertia. If you have two objects of the same volume, but one is more massive, it will be harder to move, a lot harder to slow down, or do more damage if it collides, i.e. has more momentum, etc. So next, it is the cause of gravitational attraction. Mass attracts more mass. So that tells us something. Next, we have Newton's second law, F equals ma. If you have an object, which will have a constant mass, if we have an object, it'll give you constant mass. So the more force you give, the more acceleration you'll get out of this object. So mass defines how much force you need to generate acceleration, because those two are linearly related. Lastly, mass is a quantifiable measure of energy. Think about Einstein's E equals mc squared. C squared is the speed of light squared, which will always be the same. So mass, by this equation, is the same as energy, or energy waiting to be released. So mass, how much stuff there is, it defines the relation between force and acceleration. It is a quantity which is directly, it's the same as energy in some ways, and also is a measure of inertia. So that's mass. So one thing that most people confuse is that mass is the same thing as weight. This makes sense since we're on Earth, and the Earth is a monster constant mass next to us. So gravity is essentially constant. So the more massive something is, the more weight it has on Earth. However, the same mass on the Moon will have 1/6 of the weight. Weight is equal to mass times gravity. So on Earth, they are totally linearly related. However, mass and weight are separate quantities, so be careful. You cannot use those words interchangeably. If that's the one thing you walk away with today, that is weight and mass are not the same thing. But that is the word of the day, mass. I, did my best with the definition there. It is a very difficult thing to quantify, but I think we did an all right job. So let's take a look at our killer resource for today. It's a picture from the astronomy pick of the day. And what it is a really cool periodic table, and it shows you the way that various atoms can be created. It's a periodic table that's color-coded to show you how different elements are created either via the Big Bang, supernova, man-made, large star, small star, or cosmic rays. So if you want to check that out and see how any and every element's been created, head on over to the blog, pwnphysics.blogspot.com, for a link to the astronomy pick of the day from a couple of days ago. And I think that's going to do it, guys. I think the music's taken over, and I'll let you get on with it. So hopefully I'll see you tomorrow. Thanks for tuning in, and I'll see you. Take care.
The pod bay doors are reopening. You may now resume normal life